This is the final integral. It's like the final boss you need to beat to win the game. So focus. There's a hint, which is not given here. It tells you to use a trigonometric identity and then use integration by parts. It sucks because one would normally try to motivate the theory of why you would make these choices. So I'll just give it out, not explicitly, but yeah. At least the identities, there's nothing really you can do about them. So this is the double angle identity. The sine of 2x is equal to 2 sine of x cosine of x. Here we have sine of x cosine of x, then probably I can just divide both sides by 2. So this will give me my nice answer. So I won't make a substitution for sine of 2x, I'll make half of sine of 2x. Okay, so that's already a first step towards the solution. I don't think this is an unpopular identity. Now let's not forget to divide by 2. As I said, here you need to just utilize the red part, so I color this in red to give tribute or credit to the identity that helps us with this step. So this is nicer. We instead of 3 terms, we have 2 terms. It tells you to proceed with integration by parts. Why? Because if you take the derivative of x, you get 1. So you would get an integral that would only have, let's say, the that will only have something like sine of 2x. Maybe it has cosine of 2x. I'm not sure. So to do this, we need to write the formula for integration by parts. It's equal to uv. If it's a finite definite integral, you need to sub in the values. It's uv minus a to b of v du. Now here it is obvious that if we take the derivative of x, we get 1. So that's very nice. So I'll choose u to be equal to x, because then I can take the derivative of u, which will be the derivative of x, just dx. And if I take dv to be sine of 2x dx, then here's the catch. Can you integrate this? So the derivative of what is sine 2x? Is a good question to ask. It's negative cosine of 2x, but you divide by 2. Because the derivative of cosine is negative sine, so the sine cancels out. And when you apply the chain rule to the 2x, the other 2 cancels out, roughly. Now again, differentiation and integration I don't think are the core focus of this tutorial. So I'll just hand wave this, I won't write this stuff down. So this should be my v. I've integrated my dv, I got my v, and I should be able now to integrate it into my solution. This is so lame, because integrated and integrate it. It's a word play. You get it, right? You get it. Please don't leave the video. It's not just about jokes. So u is equal to x times v. So this is v. X times this quantity from a to b minus the integral from a to b. Well, a to b are just 0 to pi over 2. And then I plug in 0 to pi over 2 again. And this is what I was talking about. So if we take v to be this, and we multiply this by du, which is just dx, then I just get an integral which has only the cosine function with some constants on the side, which is very, very, very nice. So I'll simplify the cosine function. This is a minus, I'll make it a plus. There's a coefficient of half. I'll put it outside the integral. Maybe I'll just take a big half outside. So I'll take the half from here as well. Then I get the half of this. Now this is positive and this is negative. There's a minus sign here. Then I can put this here, can put this there, and I can put a minus. This is just simplification. So it's not really, any tedious math at all. This is easy to simplify. All I need to do is just plug in pi over 2 once and then take away the value when I plug in 0. So here's what I get. I get pi over 2 cosine of 2 times pi over 2 minus 0 times cosine of 2 times 0 over 2. No, there's no 2. This is 2 times 0. So this is clearly 0. And then this is pi. So cosine of 0 is 1. Then cosine of pi is 0. If you're not sure, you can always write down cosine of... So pi is 180. It's minus 1, so I made a mistake. It's minus 1. Because cosine of 0 is 1. Cosine of 180... 2 times pi over 2 is pi. Pi is 180 degrees. So 180 is like you flip this around. 180 degrees. So it's a radical change. You get a minus 1. This is a bad way to explain it. So I'll just erase it now. But it works. This is how it works. So it's a minus. Cosine of pi is equal to minus 1. And this whole thing is 0, so we can simplify it in a moment. Maybe we can also integrate this thing. So the derivative of what is cosine of 2x? Is a good question to ask. And the answer to that is... use blue. it's sine of 2x divided by 2, right? You can check this by differentiating. So the derivative of sine is cosine, and if you apply the chain rule, you'll cancel the 2 out with the derivative of 2x. So you get cosine. So this works. I'm glad. Then finally, we just need to take half of, well, this thing is already pi over 2. There's a minus 1. This whole thing is 0. Then probably, because there's a minus here, cosine of pi is minus 1, then this will be positive. So I would get whatever value is here, and then I would add pi over 2. Because it's pi over 2 times 1, which is 1. And the minus goes with the minus. Maybe to signify it, I'll do like this. And if I want to simplify this, I write down the following. Sine of 2x divided by 2. But the first time I plug in pi over 2. And the second time I plug in 0. Now sine of 0 is 0. This whole thing is 0. And sine of 2 pi over 2. Sine of pi. So sine of 0 is 0. And I don't want to use the previous analogy, but if I use it, then probably sine of pi is also 0. Because you're at 0, you go 180 degrees. So I mean, minus of 0 is still 0. So this is also equal to 0. Then this is good because you have 1 over 2 times pi over 2. Therefore, the answer should be pi over 4. Now let me check this. And it seems like I did not get pi over 4. The answer should be pi over 8. So maybe give me a moment to look into this and see where I made a mistake, if I did. I found it. So it's not really a mistake per se, it's just an inaccuracy. The value of the integral is 4, as pi over 4. But I'm not looking at the integral, I'm looking at half of the integral. So that is really the trick to it. So the answer to this, the answer to the big integral here is half of the other integral. So we totally forgot about the last half, and we just computed this part, which is, this is our I. If you notice, this is our I, but we did not account for the half that we had. So that's why. But I'm glad there's no mistake, as in mistake that needs to be corrected. So that makes me happy. So the answer to the question itself should be half of pi over 4. Then it is pi over 8. Then that should be the real answer. This is the one you should factor in. And you should be very careful because mistakes like this could cost you a lot. Like, for example, having to reshoot the recording for this video, which I will not, because I think it's a minor mistake. But if you're on the exam, I don't think anyone's gonna pass it for you. So you probably should take care of it.